All right, so let's move on to the distributive property. This is probably the fundamental properties of algebra here. Is the distributive property. Its technical name is the distributive property of multiplication over addition. Okay? You guys have all distributed things like across parentheses, right? At some point, maybe, hopefully. If not, it's not that difficult. Let's just take a look at exercise 1 here. So they want us to multiply 4 times 15. Is it using a standard algorithm? You guys know what an algorithm is? Okay. An algorithm is just a process whereby you just keep repeating the same steps on your final result until you get the final answer, right? Computers use algorithms. You've used them before in at Cox Learning Center. I know that for sure. In the kindergarten, okay? But do you remember this? 4 times 15. Remember doing this? I know that, like with the Common Core, I don't know how much they emphasize that anymore. They use some sort of, instead of doing this, they do some sort of sorcery and wizardry. A little baffling to me, but anyway. So first thing you do is 4 times 5, which is what? So we just bring that 0 down and take that 2 up top here, right? And then 4 times 1 is 4, plus 2 is 6, right? 60. Did we really just kind of distribute that 4 across the 1's place and across the 10's place? Kind of? Okay. So let's take a look at part, and there's a big typo here, a big thing missing in part B. They want us to represent the equivalent product, and it should say, so pencil this in, 4 times 10 plus 5. That should be, I don't know how that got, anyway, it's all part of editing, the joys of it. In part B, is that really just 4 times 15? Okay. Well, we know that multiplying is kind of like repeated addition, right? Like 5 times 3 would be 3 equals 3 equals 3 equals 3 equals 3, right? So let's apply that here. 4 times 10 plus 5, wouldn't it be 10 plus 5 plus 10 plus 5, plus, et cetera, right? 4 times. So let's do that. Let's do 10 plus 5 plus 10 plus 5 plus, it's 3 plus 5, and here's the 4th one. Okay? Now let's maybe just kind of associate these. Let's take these groups at a time. What's 10 plus 5 is 15, right? Plus this 15. Plus this 15 here. Yeah? And then now let's take them 2 at a time. What's 15 and 15? Plus 30 over here. So that's 60, isn't it? Right? So kind of another way to look at it. But let's increase your mathematical sophistication just a bit. Instead of treating this as repeated addition, we'll just distribute through the parentheses. So here's the distributive property down here in this box. Okay, and it does say of multiplication over addition. That's a technical name of it. So if I have 3 numbers, A, B, and C, or use it could be any numbers at all. It works for any of them, okay? If I have A times B plus C, all I do is take the A, multiply it by the B, and then multiply it by the C. In other words, I distribute the A through it. So that equals AB plus AC. You've seen that before, right? Yeah. Probably with number, not a letter, something. The letters just say could be a number, right? So, and this is kind of a good way, like if you have to do some arithmetic in your head, and this is how I learned to do it as a kid, like when I have to maybe multiply some larger numbers that weren't in my multiplication tables in kindergarten, I could break up my numbers into like 10 plus something and then distribute it. Let's try this. Take 7 times 23. Let's rewrite this as 7 times 20 plus 3. Is that equivalent? Okay. So now, and this is a good way, if you don't have a calculator, right? You're out on the street, right? You get a drug deal going down, and you don't have a calculator, and you got to work out, all right, is this seem fair or not? And you got to do the math. So great, you can do this, okay? So let's distribute the 7. 7 times 20 is what? 140. 7 times that other 3. And now that's easy to add in your head, right? 161. Get the idea? In part B, how could I break up that 18 into something a little more easy to handle? There's different ways to do it. Do 10 plus 8, right? Distribute through that way. Or 9 plus 9, right? Yeah. I'd have at least one thing with a 10 in it. You know what else you could do? You don't have to, either of those ways will work, right? But I want you to be able to think about outside the box a little bit. Could I try this? Could I do that too? I mean, you guys know those were wrong, but I want you to see things. Is that by 18? Yeah, right? So now let's distribute through the 9. That would be, what? Yeah, not 9. Equals what? 180 minus 18, and now you can kind of do that. So in your head, you're like, okay, 180 minus 20. Ooh, but not quite 20, right? What do you got? You mean 162? Yeah. Okay? Again, all your ways would have worked. But, you know, change the brain a little bit. Okay, let's try this one down here. This is a little different. 12 times 28. And they want us to break it up like this. Here's my 12, right here. Here's my 28. I'm still going to distribute, right? But, okay, how many times will I distribute? Just twice, right? So let's do this. So let's take it, so my 12 times 28, they want us to do that. That's going to be, here's my 12, 10 plus 2 times 20 plus 8. So this is the same as distributing a monomial through, but now we're going to distribute two binomials. You guys know what monomials and binomials are? And trinomials? A monomial is a single term expression, right? One. Binomial, 2 terms, trinomial, 3 terms, etc. All right, so all we're going to do is we're going to distribute through the 10, and then what? Distribute the 2. And at some point, I would like you to stop using those silly little infantile distributing lines. I'm only using them now because they're all currently infants, and by next week they will not be, hopefully. Right? Yeah. So let's distribute twice and then combine in egg-like terms. So 10 times 20 is what? 200. 10 times 8? 80. Now I'll go to the 2. 2 times 20? And 2 times 8? Okay? Now we can maybe group these up here. We got 200 plus 80 would be 280 plus what? 56? And then what's that give you? 336? Okay? So again, if you stuck without a calculator, there's different ways to go about working out the arithmetic in your head, right? Okay, so you just distribute twice. Now, at some point, okay, I want to ask you guys, has another teacher somewhere told you a different name for doing this distributing twice? It might have started with F. First, outer, inner, last. You ever heard the word fail? Good. Okay, forget it. Okay. In the last 10 seconds, we start from the left, please. Okay. Wonderful. All right, next page. So we can also use it in expressions with variables in them, okay? And by the way, so this 5 is a monomial, this 2x plus 3 is a binomial, okay? So let's distribute the 5 through here. This should be pretty simple. What do we got? 10x plus 15. Now, should I add the 10 and 15? No. Correct. They're not like terms. They're like that, okay? Let's go over to part B. Distribute through the negative 4. Negative 20x plus negative times a negative plus what? 32. And they do not combine, they're apples and oranges, right? Okay. What about part C? What is it? That's true, yep, yep. What is x times x? X times
It's still x.
X times x. Well, like this makes sense. Like if I take something and I multiply it by itself, you're telling me it's exactly the same as when it started? What if x is 5? So what you just told me, if x was 5, you guys just told me that 5 times 5 is 5. Huh? What's 5 times 5? Yeah. So x times x is what? Huh? X squared. X squared, right? Yeah. Yes, it is. Okay. X squared plus what? 4x. There we go. Are those like terms? They are not. They're different exponents. Remember, that's an exponent of 1 right there.
The other x is an exponent of 2.
Correct. They don't combine. Okay. I'm going to have you guys try this last one on your own. I'll give you a second and see what you end up with. 5x times 2 is 10x. 5x times negative 7 would be negative. 5 times 7 is 35. X times x is x squared. You little miscreants. Now, I do prefer to write it in like standard algebraic polynomial form. You can probably see like the highest exponent start first. So I would prefer, and you don't have to depending on the, but negative, I'd write it like this. They're both correct. I won't necessarily take up any points if you don't do it, but that's generally how we like to leave things. Okay, that's standard form. Okay, so any questions on that? What in the world is x times x, people? Thank you. What's y times what? Squirrel times squirrel. We're getting something. So now they kind of apply this property to division. But remember, division is the same as multiplying by what? Nope. Fraction or a reciprocal, right? So we can make it work with division. So you have b plus c divided by a, right? Like instead of saying divided by 2, I could say 1/2 of it, 1/2 times it, right? So where's this b plus c? Instead of being divided by a, it's 1 over a times b plus c. Whatever it is. Maybe it's 1/2, maybe it's 1/5. I don't know, right? You guys with me on that? And then when I distribute this through, right, because 1 over a, let's do 1 over a times b. Remember, I could write anything over 1, right? When you multiply fractions, we go across the top and across the bottom. What's 1 times b? B, a times 1. A, see how it works? So you get b over a plus c over a. Okay? All right, so we'll use this and apply it to these problems here. So instead of 8x plus 4 divided by 2, I could write it as what times 8x plus 4? 1/2 times 8x plus 4, right? Now let's distribute through the 1/2. What's 1/2 of 8x?
4.
4x. And then 1/2 of 4 is 2. Okay? The same thing. We just turn division into multiplication again. Now we can distribute. All right, what about part B? Rewrite it how? 1/5 times parentheses. There you go. What's 1/5 of 25x? 5x minus 10. Okay? All right, I'm going to let you guys try C and D here real quick. Now, I would say with C and D, like after we get to this step here, right, you might want to rewrite it so it kind of looks like this, and then maybe put things in lowest term fraction. Maybe you'll see what I mean, but give it a try. Rewrite it. Let's do this part. And now kind of rewrite it after you distribute. Rewrite it like this up here. Just then you can do it. 1/4 of 2x, guys. Wouldn't that just be 2x over 4 minus 16 over 4? See what I mean? See what, get that? No? And what's 2 over 4 in lowest terms? So this would be 1/2 x minus what? 4. Okay, you kind of get it now? Now, try what I did here with part D. If you have any fractions, just get it in lowest terms like you did in part C, okay? So I can hear you. Are you scared? Confused? Did you understand part C?
Kind
All right, let's get past the kind of. I'm like, so, like, what part of C? I mean, this is just like the rest of them right here, right?
Well, like, I understood that one, but now I'm confused on how to do D. I understood C, but I'm confused on how to do.
You just do the exact same
12 or
thing.
something.
The what? You did 1/4 of something. So 12 will be on the bottom, you just put it in the lowest term. Everybody get anything? Yeah. Oh, yeah, I'll come in here. This is a C. What? What's that? Oh, now you're being quieter. Look, just tell me what your final answer is. Yeah. Mm-hmm. Yeah, but put that in lowest terms. You got it right. Yeah, how about negative 3/4 x plus 3/2? Well, let's do it. So 1/12 times negative 9x plus 18. Okay? So let's go right to this step here. This will be negative 9x over 12, wouldn't it? You just live with a 4 over 12, right? Right? Plus 18 over 12. Now let's get negative 9/12 in the lowest terms. Divide top and bottom by what? What do you get? Negative 3/4 x. Over here, 18 over 12. Top and bottom gets divided by, the biggest one is 6, isn't it? Over what? 3/2. You had 6/4, but you just, because you divided, wait, what'd you do? Oh, yeah, you divided by 3, but 6, you want to find the biggest one. That makes sense? Any questions on this, guys? Okay? All right, no reading question then, right? Okay, so you got the 2 assignments, right? The